I was always looking for ways how to add sound to projects, or for example toys, in a simple way where I don't have to do much of electronics and definitely not any microcontroller programming. And a website called ICStation approached me. They asked me if I want to make a review of any of their products. And having gone through their site and then the products, I found this little fellow, which is like basically an MP3 module, and I thought that this is going to be my chance to review one of these products and see if it's going to be any use for me. And after doing the initial testing, I found another one from the same site, which is this one. So I thought I would just compare the two of them. And it turns out that this specific module is quite popular, and it can be found it can be purchased from many different sites, for example from eBay. And there is quite a bit of a resource on how to use this one already on the web, because it has quite a bit of features packed into this small package. So I think my video is mainly going to be a comparison, and then probably some references of the most useful sites and videos that I have found so far. So the chip on the left is called ICSH030A. So I'm guessing the ICS stands for ICStation, the name of the website. So I would assume that that's their own product. And the other one on the right is the WTV020-SD-16P. So you can obviously see the difference. So this, the one on the right is a model where you store the audio files in an SD card, a micro SD card. It supports up to 1 gig micro SD. And the other one actually has a built-in flash memory. I don't know which one is that, but you can see there are some chips on the back side as well. So this would store the audio files in memory, and then you can play them. So both of these chips are able to drive speakers directly. So I will show you some examples. And both of them also has a non-amplified output as well. So if you want to use your own amplifier because you need more sound, then you can do that as well. Both of them has a really low standby current. So the ICS model has 0.3 milliamps, and the WTV has 60 microamps. So if they are not being used, so if there's no music being played, then they draw a really small amount of power. So they should be able to run from battery for, I don't know, many weeks or months. The ICS model only supports 8K or 15K kilohertz sampling rate, and it has a memory for about 10 minutes on the 16K memory. There is no, I didn't find anything in the documentation, but I tried uploading like a 5.5 minute audio file, and it was that went through okay. And then I uploaded a 10.5 minute audio file, and it sort of like crashed around like 90 something percent. So I think it's about 10 minutes. And the other one, again, you can use like up to a 1 gig memory card, so that can be anything. Yeah, it can be hours of music stored into that one. Another big difference again is how you use them, how you supply voltage. So the ICS model is quite nice because it accepts anything from 4.75 volts to 12 volts. So anything you have in terms of like like an old phone charger, it's going to accept. But if you have like a bigger 9 volt battery or a 12 volt power supply, that would be fine as well. So I think this is quite versatile in terms of supply voltage. And the other one is more limited, so that's 2.6 to 3.6 volts. So for example, a CR3025 or 2025, so 3 volt battery coin, or 2 of the smaller coin cells should be able to drive this one, or 2 AA batteries or something like that. So again, you have quite a few options in the lower voltage range. So as you can see, the footprint for both of them is quite small. So I think this one is 16 by 18 millimeters. This one is slightly larger, and both of them are supplied with pins. So it is really easy to use them in any project. I mean, you can plug into a breadboard, or if you build your own circuit, then you can use just a normal 0.1 inch pin headers. So the other thing is, I forgot to mention that the SD card model uses a ADPCM format, so the files are AD4 format. So there is an application available online which then which lets you convert any of your MP3s into this format that you can upload to the memory card. And finally, before I do any testing, two big differences I would like to highlight is the SD card model is pretty much designed as an MP3 player, so it has pins for starting and stopping the audio, going to the next track and going to the previous track. So that would be like, you know, like a general purpose MP3 player. Also, it has data ports, so you can drive them from a microcontroller, and then the microcontroller would instruct the player to play, you know, track 1 or track 5 or, you know, track 100. It supports up to 512 different audio files. So the next one can only support 4 audio files. So you have 4 pins. Maybe it's not these are the exact pins, but you have 4 pins, and then when you ground one of those 4 pins, then one of the audio will get played. So again, that's really nice for, as you can imagine, any simple project where you have 4 different buttons and then you want different sounds when each of the buttons is pressed. The other thing is this one has a physical volume control. So the other one has a software volume control, and it doesn't seem to work for me, so I will show you later on. So these are the big differences. Again, if you need something where you need to play shorter audio files, but you know, a couple of different ones, then that's your choice. And then if you just need something which just can play like a long audio file, then you should go for the other one with the SD card. So this is the testing of the WTV020-SD-16P. So it's hooked up in a breadboard. So here on the top I have a breadboard power supply, so it's outputting 3.3 volts. And so the schematics is really simple. I mean, you can download the documentation; it has all the details. But basically, the 3.3 volts goes to here, the ground goes to here, and then these 2 middle pins here on the left are the ones that drive the speaker directly. And by the way, that pin drives that's the non-amplified audio output. And you can see that for this one I'm using this big, relatively big speaker that, I don't know, was probably salvaged from a small radio. And then this small one also works, so that's salvaged from a kid's toy. And so I've also hooked up a LED in here. This is just a status LED, so it comes on whenever an audio is being played. So when the device is being used. I mean, I should have a small resistor connected to the LED as well. But yeah, it's going to be good for now. So if I turn it on, then the LED comes on for a short time. So controlling this module is really simple. You use this pin to start and stop the audio, and then you use these 2 pins to go to a next track or a previous track. So,
the itsy bitsy spot.
and then again here, that stops the audio, and you can see the LED goes off. So that's just the status LED, which is on when the audio is being played. So that's pretty much it. So that's the other circuit hooked up. I have now have it connected to the other side of my breadboard, so that one is on 5 volts, and you can see the top pin is the plus voltage, and this one is ground, and then the 2 pins here is hooked up to the speaker. So I'm using this small speaker now. Again, this one has a busy output, which is then linked to the LED, and I have this piece of wire which is hooked to the ground, and I can use the remaining 4 pins in here in the middle to trigger the different sounds. So the volume is turned down on this one. I think you can still probably hear, but it's much less loud than the previous one. So I've only hooked up or uploaded small audio samples to this one. Again, I'm not sure if it's coming through the recording, but so this is 8-bit sound. So obviously it's a little bit more grainy, and there is a bit of a pop sound when it starts and stops the audio. And what you have probably noticed from the video is that once it starts playing, then it just doesn't recognize any of the inputs. So first the audio segment has to complete, and then it would check if any of the other buttons pressed or any of the other pins are grounded. So that's just something that you need to take into consideration. So that's how this one operates, and again it is also possible to drive this from a microcontroller. These 2 pins here are serial data pins. So you can send commands from a microcontroller if you want to control which sounds getting played that way. And of course you can use the busy signal just for the other one to determine whether the audio is being played or not. And just like the previous model, the 3rd pin here right next to the speaker output is the non-amplified output. But all this is documented on the website. Before I go over the computer screen, I want to show the USB serial converter that I use. So that's something that I've also bought from ICStation, and I'm not sure if it's coming through the video, but it's clearly labeled. The pins are 5 volt, TX, RX and ground. And so obviously the 5 volt goes to the plus side of the chip. The ground goes to here, and then so TX and RX are these 2 pins. So RX from here goes to the TX here, and then TX here goes to RX here. So it's quite simple. And so the only additional connection it needs is this pin, which you need to connect down to the ground when you are trying to program the chip. So you need an additional wire going from here to here. So this is how it looks like when it's connected up. The 4, I got jumper wires, or just this plug wire is connected to all 4 pins on the USB converter, and it's going into to these pins here on the chip, and this piece of wire is just the is the additional ground which goes to the mode pin, which needs to be grounded for recording, and it's just like 2 pieces of wire pushed together. It's not really nice, but it's working, so just make sure that you don't touch it. So the USB is now hooked up to my computer. So if I open computer management, I can see that I have an additional COM port. It says USB serial CH030. So CH030 was the name of that USB serial converter that I got, and it says it's on COM 5. So once you download the programs that are on the website, you get this ICWave download.exe, You also get a documentation for it, which just shows you how to use the document, but it's really simple. I mean, obviously you don't get any of the WAV files. So these are WAV files I just created, quite short ones. So these are the ones that you can see that you have seen in the video previously. So now with the USB connected, you just start the application, and then you need to select the port, which is COM5 in my case, and the device, which is the ICSH030A. I'm not sure if it supports multiple devices. You click connect, and then you should get this green message, and then you browse the files that you have. So mine is stored here. So what I've done is I've named the files like 01020304 just to make, because I don't know in which order the program would pick them up, whether it's alphabetical or not, but that's the easy way to make sure that it's in the correct order. And again, all these WAV files are 8-bit and 16 kilohertz. So probably all 4 of them is less than half a minute. And once you have that, you just click download, and well, it will take some time. So it's doing this erase for I don't know, a couple of seconds. You can't really see anything on the module, so the USB has a red light which is on all the time. So you just have to wait patiently. When I uploaded the 10-minute audio segment, it was uploading for like 45 minutes. So it takes a long time to do. And as you can see, the percentage goes up really, really slow. So that's it. All the files are uploaded, so you just unplug it and you're ready to go. So next, let me show you the pages for the 2 products that I reviewed, plus the adapter board, which I don't have, and then the USB adapter that I was using to upload the samples. So that's the first page for the WTV020-SD-16P. So you can see well, it's the same product, it's the same image. You get the main product specifications, the one that I've described in the past, and then you get this product overview, which is, again, it's a terrible translation from Chinese. And funny thing, it talks about 2 different modes that I was never able to trigger. This is 4-paragraph voice and the 5-paragraph voice mode, and I was trying to find it on other websites as well, but maybe other people don't really care about these functions, so I couldn't find any reference. So this is why I just used the simple mode, which is you have a button to play and pause, and then 2 other buttons to go to next and previous voice files or tracks. And then you get this nice download button where you can download all the different programs for it. So this is the one which what was in the package. So first of all, you get this USB recorder program, which I think it's absolutely, I mean, I don't see the point of this. I don't know why it should be used. I mean, well, you don't really need any programs to put the audio files on, because you just put the SD card into your computer. And then you have this manual, which is quite extensive, and it has the same English translation from Chinese. So, I mean, yeah, you can look through, and then you can see that this product exists in many different forms. It uses the same chips, but in different formats. And then you can get the pinouts, and the pinout for the chip is that's the pinout for the package that I reviewed, and then it goes into more technical details like the different levels and how they trigger, and then the previous one. And so that's the 3-group voice mode, which I've never able to trigger, and then the other one is the 5-group of voices, and few other bits and details. But probably what was really useful for me is further down. So that explains the method, the process you use to get the data onto your to get your microcontroller to talk to this board. So this is how you instruct to play the first audio and the second and the third and number 512. And then again some signal, blah blah blah, and then some coding bit. I don't really care about this one. And then further down I just wanted to show you this one. Also that's a different package, so I don't care about this. Yeah, that's my circuit diagram. Well, actually this is the inner circuit of the module, but that's the application diagram or the application circuit that you use. So you can see that, you know, in my demonstration I didn't use the reset, I didn't use the volumes, so I just hooked up my earth wire to the play pose, the next and the previous, and that's my LED connected obviously without the resistor, and the speaker is connected here. So really simple. And there are further other application diagrams how you would use it if you want to have an external amplifier, and some other diagrams about these other modes that I was never able to trigger. So that's pretty much of the I mean, it doesn't really need any documentation. And then I'm going to link in the article I found for the actual converter, how to convert audio. So the one thing you have to keep in mind that it requires the audio files to be stored in with a specific naming convention. So it has to be 000 and then 001, and then it goes all the way to 0512.A4D. So the files have to be in this name on the SD card. But once you have these files, you just basically copy them to the SD card. So that's pretty much about it, about the the WTV020. So the next one is the ICSH030A, which was the simple 4-channel or 4 audio playback module. And again, you get the main features, and then you get the pins, and you get a simple application diagram. So you have the speaker, you have the supply voltage, and the 4 buttons to activate the 4 sounds, and then you have a piece of technical drawing, and that's the additional product I was talking about. So that's the one where it's the 4 buttons and a speaker jack, and the USB is integrated into like a small board, so you can use this for programming the chip if you don't want to hook your wires up manually, or to also test it. So, but if you don't want to do that, then obviously now you have this download button again, which then gives you all these documents. So in the download you find these 2 files, and then you also find a wave editor, which I think it's completely useless because it's pretty much all Chinese. So I got rid of that straight away, and so I'm using my own audio processing program. So anyway, so that was the Wave Download Exe, which would let you download the audio files, and then it has a program documentation for it. The only thing which is worth noting about the documentation is this diagram. So that's the one that I use to hook up my USB TTL converter to the chip. So as I said, you get the 5 volts from the USB, and then you ground. You hook up the ground here, and then the ground also needs to go over to this mode pin. And then, as I said, RX goes to TX, and then TX goes to RX. And that's pretty much it. And after that, you just run the program, and then you do the steps that I've shown before. So that's about the program for the ICS chip. So the next product is this test board. Again, it's specifically designed for this ICS chip, which then the USB part of it would let you program it, and then the 4 buttons will let you test it. So you don't have to plug wires on your own, and so it's simple as that. And then, so you either have that, or if you want to have a really cheap USB TTL converter, then that's the one that you can go for. So that's the one I bought, and you can see it's the one that I have in the video. And if you want to use the WTV020-SD-16P for your project, then if you just put it into Google, the second and the third hit is the one that I've looked at, and those are really useful. So the second link is in buildcircuit.com, and then it's quite extensive because well, it's one of the few articles about this device, because if you scroll further down, then in the related tutorials you can read about the module, what's the MP3 mode, how to use it with audio amplifier, and then you have a couple of samples with how to use it with Arduino, and most importantly how to convert the MP3 into 84 format. So that's the page I use to download the converter as well, and so it takes you through the different steps, how you convert your audio to mono, how you save it, and then how to use this program, the AD4converter.exe. So it is really simple. And of course, this buildcircuit.com website is again, it's really nice. So it also has some videos, and so for example, this example shows how you can use the Arduino to control this chip and then play the audio. And you can see there are some nice photos and schematic diagrams how to hook up the different components. So that is one that really useful. And if you would like to go down the Arduino route, then there is this post on the Arduino forum with a code sample, how you send various commands to this chip to play, you know, the to start and stop the audio, and then you play selected audio files. So again, it's all documented nicely here. So that was my review of the WTV020-SD-16P and the ICSH030A sound modules. Both of them I got from www.icstation.com. Thank you for watching.